Okay, my friends, so we're going to follow up here with example 1, table of values that matches the first part. So it looks like Becky has months 0 through 6 and then the account balance. So we can add that to the board up here. So we'll do that. Months. And then we got 0, 1, 2, 3. I'm going to run out of space. I'm going to go to 4 if that's okay. What the hell? I'll squeeze it in. 5, 6, because you would have done this, so I'll do it too. Okay, balance. Now, if I remember correctly, the plot actually started at month 1 with $400, right? And then there were $300 saved every additional month, so it went to 700, then 1,000, then 1,300, then 1,600, and then 1,900. Yep. Okay. And then actually we reverse engineered what month 0 was. Month 0 would have been when he opened the account and we figured out he must have put $100 in it because he's investing $300 every month. Okay, cool. What is the y-intercept? The starting point. We just figured it out. The y-intercept, if you graph this thing, which we're going to do in a minute in Sheets. I don't know if we'll graph this one, but we'll graph something in Sheets. We haven't really talked about why this is a line yet. We'll get to it. If you connect those points with a line, as I'm doing right here on the screen, you'll see that the line hits the y-axis. Now, the y-axis is where x equals 0. Making some assumptions here that you remember this stuff from your previous math classes. X-axis is the horizontal, y-axis is the vertical. If you back that line up, it's going to smack into the y-axis, and that's the value on the y-axis that it equals when it hits that y-axis. Those are all zeros. So that's the y-intercept. It's where x equals 0. It's whatever the y value is there. What is it about these numbers that tells us it's a linear relationship? Well, that's kind of the point, right? So the whole point of this is what makes that line a line, as you just saw on that image we had. Well, there's actually 2 different things that are making it a line. First of all, the months are increasing in a consistent number. Plus 1, plus 1, plus 1. So the data is jumping by 1 each time. That's part of it. But that alone isn't enough. It's that combined with the jumping that's happening over here. Plus $300. Plus $300. Plus $300, and so forth, all the way down. So that it's both of these things together. Sorry, this is getting a little bit sloppy. Plus $300, plus $300. It's both of those things taken together. It's the fact that as the months goes up by an amount, the balance goes up by an amount. Not the same amount. That's not equal to this. But this change is consistent and this change is consistent. That's what makes it linear. If any one of those things becomes inconsistent, you get all kinds of other wonderfully mathematical kinds of things. But in lines, as the independent or x values change consistently, so do the y values. All right, and which leads us right into the next one. What is the slope, rate of change, that's what's going on here, of this relationship, including units? Okay, I'm going to clear a little bit of space here, I think. Yep, I'm going to clear a little bit of space because I need some board. I think we have enough already on the board to answer this question. So the rate of change, you're interested in how the balance is changing. That's what you're interested in, right? I mean, yeah, the months are important to talk about the speed at which it's changing, but really what's important is the balance, so the y. So when Becky mentions the slope or the rate of change, it's how much the balance is changing each month. So the slope, or I like to call it the average rate of change personally, and you'll see why when we get later on with some other data. I call it the average rate of change. Average rate of change. Mostly because I love that phrase, because you can acronym it. A-Rock, which reminds me of the Beastie Boys and Ad-Rock, but, showing my Gen X tendencies here. So what is the slope? Average rate of change. We talk about slope. I feel like we've talked about this in class before. We did. I forget when. But I asked you to give you as many things as you can remember about slope. Basically, the most uniform kind of definition of it is, how is the y changing compared to how the x is changing? How is the dependent variable changing depending on how the independent variable is changing? So here, for this particular example, it's going to be, how is the balance changing as time changes? Well, we know two numbers, right? The balance is changing $300. But how often is the balance changing $300? It's changing $300 each month. So thinking back to Math 98, the unit fraction here is a change of positive $300 per 1 month. And that, my dear friends, is literally, that's a T. That's literally the rate of change, the slope of this model. $300 every 1 month. And the units are important, and we're going to see, I've got a feeling we're going to see why pretty soon as we go through the rest of this. So there's your slope. Yeah, write an equation, okay, that describes Bob's savings. Okay, so this is where we're going to get a little bit algebraic. We're going to keep that number in mind. All right, so this is not an algebra class, but we're going to bust a little bit of algebra here. Just a little tiny bit. This is how we ended Math 98, so we're going to kind of pick up where we left off there. You're interested in how much money Bob has in the account, okay? Or balance, let's call it the balance, because that's the language we're using. Balance in the account. But it's not just the balance in the account. It's the balance in the account after a certain number of months have passed. So let's make after a certain number of months. Okay, this is cumbersome. Big words. This is where algebra is our friend. We're going to make those words variables. So the balance in the account. Get some colored chalk up here. We'll go with blue for balance in the account, and we'll go with like a pink for months. Okay, so the balance in the account. Let's just call this B for balance. Cool. After a certain number of months, we'll call that N for the number of months, or M if you want to use for months, whatever you want to use. You can make either of these things equal anything. Super traditional math folks are going to call it Y and X for the X and Y axes. So the balance in the account, B, I'll use the colors we just did, is going to be equal to, let's think about this. After 1 month it had 400. 2 months it had 700. 3 months it had 1,000. Okay. Let's just think about how the money grows. When it started, when there were no months, when N was 0, Bob started by putting $100 in it. And that $100, since we're not accruing interest, is just sitting in the account still. It's at the, I mean, if you imagine this account as money being thrown into a bucket, that $100 is sitting on the bottom. Each month, plus each month, he's going to add $300. So if you add $300 N times, you've got N times 300. And that, my dear friends, I think is a pretty good equation that describes what's going on in this guy's bank account. Now, you may have written it a different way. I know a lot of folks, I think I talked about this maybe early in the course. I think a lot of you wrote y equals mx plus b. That's a very classic expression of a linear relationship. In this case, m, which is the slope, would be this 300. X is the independent variable, that would be this n, and b is the y-intercept, I don't know why it's called b, which would be the 100. My brain thinks of it this way. When you're building Bob's bank account balance, that was a lot of b's. When you're building Bob's balance, then you're going to start with the $100 and then just keep adding $300 a number of times until you get there, which I think is then the next question too. How much money would Bob have after 3 years? And how much money would Bob have after 50 years? So we'll do 3 first. Okay, no, I'm not. I'm gonna erase that. Nope. I'm gonna leave this here just so we have that constant reminder of what we're actually solving for. So what amount of money does Bob have after 3 years? Okay, so the first thing you have to remember is we're looking for the balance, right? We're looking for how much he has in the account. We know it starts with $100. But now I'm telling you, or Becky's telling you, how long we're depositing money for. 3 years. Don't plug 3 in for n, because n is in months. So 3 years is 36 months. Right? 36 months times $300 per 1 month. Remember that $300, I should have written this in the original equation when I had it on the board. That $300 is not just $300, it's $300 every month. And now, because dimensional analysis never really leaves us behind, the months divide off, and we end up multiplying the 36 months times 300, which if I can do that math in my head, let's see, I've got 18 carry the 1, that's going to be $1,080. I'm just going to go ahead and insert a voiceover here that Sean did the mental math wrong. He's missing a 0. Yeah, look at you trying to do math in your head. It's not $1,080, it's $10,800, which means that the grand total is going to be $10,800 plus 100 more dollars, which is going to be $10,900. Way to go there, buddy. Let's see if he does better with the 50 years. We got to take it out. 50. Look at that chalk. Except we gotta go 50 years. Okay, so the slope is still gonna be $300 per every 1 month. But 50 years at 12 months years, 600 months. 600 months. Okay, but the months still divide off. So all we gotta do now is figure out what the hell that is. So that's gonna be $180,000 if I'm doing the math right? It's 6 times 3 is 18, and then 4 zeros. So that's gonna be $100 plus $180,000, which is gonna give us $180,100. $180,100. And the question is it even a reasonable question to ask, or are we extrapolating too far? I would say in general, extrapolating means, well, it means a couple different things. In this case, what Becky is asking, which is a great question, is does it make sense to think that you can save? Who's Bob again? Let me read back to what Bob's situation was. I forget what his student situation was with this. It was something about college student. No, I actually don't think it makes sense to extrapolate. He's a college student. I mean, is he going to be in college for 50 years? But then you could come back, well, maybe he just kept the account going after he graduated. Yeah, I'll let you wrestle with that. We could chat about that more when we're back in class together. All right, read the next little bit.